Ratites are a truly remarkable group of birds. They are a living testament to a road less travelled in avian evolution. When we think of a bird, we almost invariably picture a creature of the air, a master of flight. But the Ratites chose a different path. They surrendered the skies and, in doing so, conquered the land. This group includes some of the most iconic and impressive birds on our planet. The towering ostrich of Africa, the fleet-footed emu of Australia, the elusive cassowary, the rheas of South America, and the nocturnal, secretive kiwi of New Zealand. They are birds, yet they are bound to the earth, a paradox that makes them endlessly fascinating. What truly defines a ratite is hidden beneath its feathers. It is a feature of its skeleton. Most birds possess a prominent keel-shaped bone on their sternum or breastbone. This keel acts as a vital anchor point for the powerful flight muscles needed to beat their wings against the air and achieve lift. The Ratites, however, lack this structure entirely. Living a life on the ground requires a completely different set of tools than a life in the air. The Ratite body plan is a masterclass in this terrestrial adaptation. Where a flying bird is a marvel of lightweight engineering, a Ratite is a powerhouse of bone and muscle. Their legs are their engines, often long and phenomenally strong, capable of delivering powerful kicks for defense or achieving bursts of speed. The ostrich, for example, can sprint at over 70 kilometers per hour, its two-toed feet pounding the savanna with astonishing force, each stride covering up to 5 meters. Their feathers also tell a story of a life without flight. The feathers of a flying bird are a complex interlocking structure, tiny barbules hooked together to form a stiff, flat vane, creating an airfoil that can catch the wind. Ratite feathers are much simpler. They are soft, shaggy, and almost hair-like, lacking the intricate hooks that bind them together. They provide excellent insulation against the heat of the day and the cold of the night, but they could never generate the lift required for flight, giving these birds a distinctly prehistoric and shaggy appearance, a coat perfectly suited for a creature of the land. Diet and digestion are also uniquely adapted to their lifestyle. Many Ratites are omnivores. They will graze on grasses and browse on leaves, but they also eagerly consume fallen fruits, seeds, insects, and even small lizards or rodents. Lacking complex teeth, they swallow their food whole, often ingesting small stones, known as gizzard stones or gastroliths. These stones remain in their muscular gizzard, where they act like millstones, grinding down tough plant fibers and hard seeds, helping the bird to extract every last bit of nutrition from its meal. Perhaps one of the most interesting shared traits is their reproductive strategy. Ratite chicks are what we call precocial. This means that shortly after breaking free from the egg, they are already on their feet, covered in downy feathers and able to walk, run and forage for themselves. They are not helpless nestlings that must be fed by their parents for weeks. This is a crucial adaptation for a ground-dwelling bird, as a static nest full of helpless young would be an easy target for predators. Instead, the family can be mobile, following the parent as they learn the vital skills of survival from day one. Today, the Ratite family is spread across the southern hemisphere, a living map of an ancient world. The most famous and largest of them all is the ostrich, the undisputed king of the African savanna. Living in nomadic groups, these giants use their incredible height and sharp eyesight to spot danger from afar. A male, with his dramatic black and white plumage, will often preside over a harem of more plainly feathered females. It is a communal affair. The females lay their enormous eggs in a single shared scrape in the dirt, creating a massive clutch that the dominant male and female will take turns incubating. Across the Indian Ocean in Australia, we find the emu. Second only to the ostrich in height, the emu is a wanderer, a shaggy brown bird perfectly at home in the woodlands and plains of the outback. Emu society is quite different. After the female lays her large dark green eggs, her job is done. It is the male who undertakes the arduous task of incubation. For nearly 2 months, he will sit fast on the nest, rarely eating or drinking, losing a significant portion of his body weight. He then guards and guides the stripy camouflage chicks for many months, a devoted and solitary father. Deep within the ancient tropical rainforests of New Guinea and northeastern Australia, a living relic of a bygone era stalks the forest floor. This is the southern cassowary, the most striking and perhaps most formidable of all ratites. With an almost prehistoric presence, this shy and solitary bird navigates its dense, humid world with a quiet intensity. It is a creature of shadows and dappled light, rarely seen but always felt. Its body is cloaked in a dense coat of glossy hair-like black feathers, which offer protection from the thorny undergrowth. This dark canvas provides a stark contrast to the brilliant featherless skin of its neck and head, which blaze with electric blues and deep reds. These vibrant colours can change in intensity depending on the bird's mood, acting as a silent, vivid form of communication. Crowning its head is a strange, bony helmet, or casque. The exact purpose of this unique structure remains a subject of scientific debate. It may serve as a tool to push aside jungle vines, a symbol of dominance, or even a resonator to amplify its deep, booming calls that echo through the forest. The cassowary is absolutely vital to the health of its forest home, acting as a mega-gardener. It swallows large fruits whole, a feat impossible for smaller animals. Later, it deposits the seeds, perfectly fertilized in its droppings, often miles away from the parent tree. Many plant species have evolved seeds so large that only the cassowary can disperse them, making this bird a true keystone species, single-handedly shaping the future of the rainforest. While reclusive, a cornered or threatened cassowary can be incredibly dangerous, earning it the title of the world's most dangerous bird. Its primary defense is a formidable dagger-like claw on its inner toe, which can reach up to 5 inches long. With a powerful kick, it can use this weapon with devastating and sometimes lethal effect, a stark reminder of its wild, untamable nature. Across the Pacific, in the vast open grasslands of South America, roam the rheas. Looking like a smaller, greyer and more slender version of an ostrich, these birds are built for life on the pampas. Unlike the solitary cassowary, rheas are social creatures, often living in flocks that can number from a few individuals to several dozen, moving together in a constant search for food. Their social life is complex and centers around a fascinating breeding system. During the mating season, dominant males compete for the attention of females through elaborate displays. A successful male will mate with several females, sometimes up to a dozen. But here the roles reverse. The females then lay their large cream-coloured eggs in a single communal nest prepared by the male. Once the eggs are laid, the females depart, leaving the male to take on all incubation and parenting duties. For over a month, he will diligently guard the nest. After they hatch, he becomes a devoted father, sometimes leading a large creche of chicks from multiple mothers, fiercely protecting them from any perceived threat. Finally, we travel to the forests of New Zealand to find the smallest and perhaps oddest member of the ratite family. The kiwi. This is a bird that breaks all the avian rules. Small, nocturnal and flightless, its pear-shaped body is covered in shaggy hair-like feathers. It is a bird that behaves more like a mammal, occupying a similar ecological niche to a badger or hedgehog. Kiwis are unique among birds for their highly developed sense of smell, a trait almost unheard of in the avian world. Their nostrils are located at the very tip of their long, sensitive bill, allowing them to literally sniff out their prey. Under the cover of darkness, they use this remarkable adaptation to probe the soft forest floor, detecting the scent of earthworms, grubs, and fallen fruit buried deep in the leaf litter. With poor eyesight, their world is one built on touch and smell, a truly unique way of life for a truly unique bird. Section 4. Ghosts of Gondwana, the Lost Titans. The Ratites we see today are impressive, but they are merely the survivors of a lineage that once included true giants. Their story is haunted by the ghosts of even larger species, birds of a scale that is difficult to imagine. For millions of years, the islands of New Zealand were a land of birds, with no native land mammals to prey on them. In this safe haven, a diverse group of ratites, known as the moa, evolved. There were 9 different species, ranging from the size of a turkey to the colossal giant moa, which stood over 3 meters tall and had no wings whatsoever. These birds were the dominant herbivores of ancient New Zealand, browsing on trees and shrubs in a way that shaped the very structure of the forest. For millennia, they lived in peace. But their world was shattered with the arrival of the first humans, the Maori, around the year 1300. To the new settlers, the moa were a seemingly endless source of food, large, slow. Within just 1 or 2 centuries of relentless hunting and habitat alteration, all 9 species were driven to extinction. Their bones, found in vast numbers in swamps and caves, are a silent, tragic monument to how quickly a new predator can wipe out a species that has never known fear. Half a world away, on the island of Madagascar, lived another group of ratite titans, the elephant birds. While not as tall as the largest moa, they were far more massive. The largest species, Varombe titan, was the heaviest bird known to have ever existed, weighing perhaps up to 700 kilograms or more. They were stout, immensely powerful birds that stomped through the forests and woodlands of Madagascar. Their legacy survives today in the form of their eggs, which are the largest single cells known in the animal kingdom, bigger than a rugby ball and with a volume equivalent to around 150 chicken eggs. Like the moa, the elephant birds thrived in an environment free from large predators. And like the moa, their demise appears to be linked to the arrival of humans on the island, while direct evidence of hunting is scarcer than for the moa. Section 5. A tale of drifting continents and flying ancestors. For many years, the global distribution of ratites, the family of large, flightless birds we've been exploring, seemed to present a simple, elegant picture of evolution. It was a puzzle that appeared to solve itself with a single, beautiful idea. Scientists looked at a map and saw these magnificent birds grounded on continents separated by vast, impassable oceans. They found ostriches in Africa, rheas in South America, emus and cassowaries in Australia, and the extinct moa in New Zealand. The connection wasn't the birds themselves, but the land beneath their feet. These continents were once connected, puzzle pieces of a single, immense southern supercontinent known as Gondwana. The theory that emerged was as grand as the supercontinent itself. It proposed that a common, flightless ancestor of all Ratites roamed this unified landmass millions of years ago. This ancestral bird didn't need to fly, because its entire world was a single walkable expanse. Then, as the colossal forces of plate tectonics began their work, Gondwana fragmented. Starting around 180 million years ago, the continents drifted apart. Populations of this ancestor were carried along for the ride, passive passengers on these colossal continental rafts. Isolated on their new island continents, each group began a separate evolutionary journey, adapting to their unique environments and evolving into the distinct species we know today: the ostriches, rheas, and emus. This idea, known as the vicariance model, was a compelling and widely accepted explanation. It beautifully tied together the fields of geology and biology, suggesting the birds were simply witnesses to a planetary-scale breakup. It painted a picture of a single ancient lineage splitting apart not by its own power, but because the world itself split apart beneath it. For a long time, this was the accepted story. It seemed to make perfect, intuitive sense. After all, these birds couldn't fly. How else could they have possibly crossed the thousands of kilometers of open ocean that now separate their homes? The continents themselves must have carried them. It was a story of evolution on a truly geological timescale, slow, steady, and magnificent. However, science is a process of constant refinement, and even the most elegant theories must stand up to new evidence. Recent advances in genetic analysis, a tool unimaginable to the theory's original proponents, have turned this simple story on its head. The ability to read the history written in the very DNA of these birds has revealed a much more complex and, frankly, more dynamic history. By comparing the DNA of living and extinct Ratites, scientists have been able to build a more accurate family tree, a molecular clock that measures the time since different lineages diverged. The dates this clock revealed didn't align with the geological timeline of continental drift. The branches of the family tree were too young. This new evidence points to something startling, a conclusion that completely reframes the narrative. The common ancestors of modern Ratites could fly. They were not hulking, ground-dwelling giants, but likely smaller, flight-capable birds. These flying ancestors were able to cross oceans and colonize the various continents and islands long after the breakup of Gondwana was well underway. This means that flightlessness did not evolve just once in a single ancient ancestor. Instead, it evolved independently, time and time again, in different lineages on different landmasses. This is a stunning example of convergent evolution, where unrelated or distantly related species evolve similar traits in response to similar environmental pressures. Once these flying birds arrived in a new land with few or no ground predators, the immense energy cost of flight became an unnecessary luxury. Losing flight allowed them to save energy and invest it instead in growing larger and larger, a winning strategy that was repeated from Africa to New Zealand. Section 6. Architects of the ecosystem. In any great wilderness, the largest animals leave the deepest mark. Their sheer size and presence can alter the physical world around them, creating paths, clearing vegetation, and cycling nutrients on a grand scale. They are the heavy machinery of nature. And the Ratites, the giants of the bird world, are no exception. They are not merely inhabitants of their ecosystems. They are active architects, shaping the very landscape they call home, through a powerful, life-giving partnership with the plant kingdom. Through their daily relentless search for food, they play a crucial role as megafaunal seed dispersers. It's a vital service, a job for which many plants are entirely dependent on them for their very survival. The southern cassowary of New Guinea's rainforests is perhaps the ultimate example of this profound connection. It is one of the few creatures large enough to swallow the big, fleshy fruits of many rainforest trees whole, a feat impossible for smaller birds or mammals. After its meal, the bird then wanders for miles through its vast forest territory before depositing the seeds, unharmed, in its droppings. This process is far more than simple transportation. It is a sophisticated and essential form of cultivation. The journey through the cassowary's digestive tract, aided by the grinding action of stones in its gizzard, can scarify the seed's hard, protective coat. This physical abrasion is the precise trigger needed to break dormancy and initiate germination. The seed is then delivered in its own personal pile of high-quality, nitrogen-rich fertilizer, giving it a perfect head start in life, far from the competitive shadow and pathogens surrounding the parent tree. Dozens of tree species, some with seeds so large they have no other dispersal agent, rely so heavily on the cassowary that they are known as cassowary plants. Without this giant flightless gardener, the very composition, structure, and long-term health of the entire rainforest would be profoundly different. Its disappearance would leave a silence not just in sound, but in the ancient cyclical life of the forest itself. This story of ecological engineering repeats itself across continents. On the open plains of Africa and South America, ostriches and rheas perform a similar, though less specialized, function. While they consume a more varied diet that includes insects and small reptiles, they also ingest a wide variety of seeds. Their long-distance movements ensure that these seeds are spread far and wide across the savanna, promoting genetic diversity and helping to colonize new areas. In these vast open spaces, they are the tireless sowers, ensuring the grasslands remain a vibrant and resilient mosaic of life. Perform a similar, if less dramatic, function. As they graze and browse, they consume vast quantities of seeds. While their gizzards destroy many, others pass through unharmed and are scattered across the landscape. Their movements, often covering great distances in search of fresh vegetation, ensure that plants can colonize new areas. Their feeding habits also influence the structure of the vegetation. By selectively eating certain plants, they prevent any single species from becoming too dominant, thereby helping to maintain the diversity of the grassland ecosystem. Even the smallest ratite, the kiwi, has a significant impact on its home. As it probes the damp forest floor with its long beak, it aerates the soil, much like an earthworm. This constant turnover of the leaf litter and topsoil helps to break down organic matter and recycle nutrients, enriching the soil for the plants and trees around it. These birds, from the largest to the smallest, are not just passive consumers. Section 7, A Precarious Future and Our Shared Responsibility. The story of the Ratites is a powerful drama of survival and extinction, a story in which humanity has become the lead actor. The fate of the moa and the elephant bird serves as a stark and sobering warning. These giants had thrived for millions of years and were extinguished in the blink of a geological eye following the arrival of humans. Their size and flightlessness made them vulnerable. Our ancestors, armed with new hunting techniques and a need for resources, proved to be a force of nature they could not withstand. Their extinction demonstrates how fragile even the largest animals can be. Today, the remaining Ratites face a new and complex array of threats, nearly all man-made. Habitat loss is chief among them. As forests are cleared for agriculture and grasslands are converted for grazing or urban development, the territories these birds need are shrinking and fragmenting. Roads cut through their ancient roaming paths, leading to vehicle collisions. Fences block migratory routes, cutting them off from food and water. For wide-ranging birds like the emu, this fragmentation is a slow but certain threat. For island-dwelling species, the danger is even more acute. The kiwi of New Zealand evolved in a land without predatory mammals. It has no defense against dogs, cats and stoats. These introduced predators now kill thousands of kiwis, particularly vulnerable chicks, every year. In Australia and New Guinea, cassowary populations are threatened by feral pigs, which compete for food and can prey on eggs and young, as well as by habitat loss and dangerous encounters with cars and domestic dogs on the fringes of their shrinking rainforest homes. The Ratites are more than just a collection of quirky, flightless birds. They are living history, a direct link to a deeper, wilder past. They remind us that evolution is not a simple ladder of progress, but a branching tree of endless, wonderful possibilities. Protecting them is about more than saving a few species. It is about preserving entire chapters of Earth's biological story. To secure their future, we must protect their habitats, control the invasive species we have unleashed, and find ways to coexist. By safeguarding these grounded giants, we honor our planet's ancient heritage and accept our profound responsibility as its current custodians.